Hello everyone. Today we will solve three important questions on ray optics. Plus, stay tuned as we will tackle a few more problems on ray optics in our upcoming physics videos. Now, let's start with this question which says, if two mirrors are kept at 60 degrees to each other, then the number of images formed by them is. So they are telling that there are two mirrors and they are kept at 60 degrees to each other. Now they are asking for us to find out the number of images formed by those two mirrors if they are kept at 60 degrees. So to solve this kind of a question, we have to use a formula which is n is equal to 360 degrees divided by theta minus 1. So this formula is used for calculating the number of images formed when two or more plane mirrors are placed at an angle theta to each other. Okay, this is used for plane mirrors. So what are the information that they have given in the question? They have given us that two mirrors are kept at 60 degrees. So theta is 60 degrees. Now they are asking for number of images, n. What is n? Directly substitute these information into the formula. So n is what we have to find out. So n is equal to 360 divided by 60 minus 1. Gets cancelled out and this is 6 times. So n is equal to 6 minus 1, which implies n is equal to 5. So the answer for this one is option A, 5. That was easy, right? So we have a similar kind of question next coming up. So the next question is, to get three images of a single object, one should have two plane mirrors at an angle of. So here they are asking us to find out the angle to get three images. Okay, when two plane mirrors are kept at an angle theta. So what we have to find here is theta. And they have given we have to get three images. So n is equal to 3. So what is the formula? The formula is n is equal to 360 divided by theta minus 1. So n is given to be 3. So 3 is equal to theta is what we have to find out. So 3 is equal to 360 divided by theta minus 1 goes here. So plus 1. 4 is equal to 360 divided by theta. So theta is equal to 90 degrees. So the option is option B, 90 degrees. Moving on to the next question. A light ray is incident perpendicularly to one face of a 90-degree prism and is totally internally reflected at glass air interface. If the angle of reflection is 45 degrees, we conclude that the refractive index n is. So here are the options. Let's solve this question now. So they are saying that there is a 90-degree prism. So 90-degree prism is here and there is a light ray which perpendicularly goes into the 90-degree prism, as you can see here, and it is totally internally reflected. So totally internally reflected in the sense this one goes, you know that whenever light ray passes through a glass from a rarer medium to a denser medium, there occurs refraction, right? But for this total internal reflection to take place, you know that there is a condition for it, which is when the incident angle is greater than the critical angle, only then this total internal reflection occurs. Okay, so there is a condition of total internal reflection where the incident angle is greater than the critical angle. You'll have to remember this thing, and this is very important for total internal reflection. Okay, because the incident angle is greater than the critical angle, there happens a total internal reflection, and that's why instead of this light ray, incident light ray, going outside the prism in a different angle, it travels through the glass prism itself. It gets reflected in the glass prism itself. If the angle of reflection is 45 degrees, so they are saying that if the angle of reflection over here is 45 degrees, they are asking us to find out the refractive index. Okay, I hope the question was clear. So see here, they have given the angle of reflection to be 45 degrees. So this is 45 degrees. This is the, I'm really very sorry. The angle of reflection is what they have given here. Okay, so this is incident, this is incident, this is a reflection. Okay, we know that angle of reflection or angle of incidence is equal to angle of reflection. Since they have given angle of reflection to be 45 degrees, so this is going to be 45 degrees. So this is also going to be 45 degrees. Okay, know this. Now they are asking us to find out the refractive index. Applying the formula or the condition that we have for total internal reflection, which is incident angle I greater than critical angle C. Okay, now multiply sine on both the sides. Okay, if you do so, you get sine I greater than sine C. From here, 1 minute, from here you know that I is equal to 45 degrees, because from this line we found out that angle of reflection is 45 degrees, and we know that angle of reflection is equal to angle of incidence, and hence this 45 is equal to this angle of incidence, which is also 45, and hence I can write instead of this I 45. Okay, so sine 45 greater than sine C. So this is sine 45 is 1 by root 2 greater than sine C. Also, we know that sine C is equal to 1 by n, where n is the refractive index. Since they are asking for the refractive index, instead of this sine C, I am writing it to be 1 by n. We have this formula, remember this one, note this one as well. So instead of sine C, I am going to replace it by 1 by n. So 1 by root 2 greater than 1 by n. Taking this n over here, to do that you'll have to multiply n here and n here, so that this n gets cancelled out over here and n comes here on the left side. So n by root 2 greater than 1. So n, taking this root 2 over here, to do that we'll have to multiply root 2 here and root 2 here, so that root 2 gets cancelled on the left side and it comes on the right side because we have multiplied root 2 on the right side. So n is greater than root 2. This is the final answer. So option B, n greater than root 2 is the right answer. I hope everything was clear to you. See you in the next video. Thank you for watching.